recorded. Yes, this can be recorded. Thank you, Kevin.
Awesome. Thank you so much, both Melissa and Alicia, for inviting me and having me here. Let's see, can you see my slides?
Yes, we can see your slides.
Perfect. And I guess you can also hear me since you just responded.
Yeah, we can do that too.
Yeah, let me know if anything like it doesn't work or so. Feel free to enter in the chat or elsewhere. Let's see. Let me just make sure I have the chat open as well so I can see everything. Cool, great. Yeah, again, thank you so much for having me. Glad about the turnout. Happy that so many people are here. Yeah, so I think today we're going to talk about. Let's go down. We've been here already. We're going to talk about web application development. Maybe before we go there, let me introduce myself. So my name is Sascha Heberling. I work for a company that you might have heard about called Google. I've been there now for the last 13 years. I'm a tech lead manager for a team that used to be in Daydream, but did a whole bunch of stuff before reaching that project. So a bunch of stuff that's actually very relevant to web development. I actually started out, fun fact, as an exchange student at SF State in 2005. So I've actually studied there for one semester, which was a lot of fun. But then, yeah, after finishing my master's in Germany, joined Google. I worked on something called the Google Web Toolkit, which is not so active anymore today. So we're not going to talk about that today, but that actually used to be an interesting web development toolkit where you could write your application in Java and it would cross-compile over into JavaScript. And you could write your whole web application in Java. That was especially relevant back then when browsers were very different, but nowadays things have changed. So that's not a product or a framework that I would worry about too much, but it was pretty cool to work on back then. Then worked on Google Maps and something called iGoogle that probably most here don't remember. I was one of the two inventors of Photosphere, which is on Android phones still today, which lets you take panoramic images. Was then a tech lead on Android itself for the camera app. And again, then used to end up in Daydream. Worked on a bunch of Nexus and then Pixel cameras. So that was a lot of fun, bringing it kind of like from an underdog position to a place where it was then basically leading mobile photography. That was a lot of fun. And yeah, today I'm working for Google's teleportation organization, working on some cool stuff that we can hopefully talk about more soon. But that's kind of it about me and what I've been doing. Let's talk about the topic today. Oh yeah, a few disclaimers. I just have to add this slide, right? So I'm not here on behalf of Google. I'm here on behalf of myself. So all the views here are mine, not those of Google. And then also disclaimer too, yeah, web development obviously is a very complicated, or not complicated, but very complex topic, right? There's, if you talk about web development, there's all the backend development, and then there's all the front-end development. I'm trying to cover it all today in like about an hour-ish, so it's quite a lot of stuff. But I know I tried to find a way to basically bring like both ends of this equation into this, and give you like one or two examples of representative technology that you can use both on the back end as well as on the front end. So yeah, I hope this is helpful. Also, feel free to interrupt me at any point in time, unmute, write something in the chat. I'm definitely, the more interactive we can make this, the better it is. I'm also not just going through slides. I'm trying to switch between the slides, my editors, my terminal, so we can actually see these things live running. So of course, I hope the demo gods are with us and this will all actually work and not crash and burn. Cool. With that said, obligatory like overview slide, right? So when we talk about web development or web application development, what does it mean? Of course, most of you probably have heard about this at one point or another, but when you think about a web application, there are a lot of things like Gmail is a web application, Google Calendar, every website in a way is a web application. So obviously you view these things in your web client or your browser, like Firefox, Safari, Chrome, what have you. And you know, that's where you view them in. But of course, they're also like all this data is being served from somewhere. So there are a lot of different server technologies serving you the application in different bits and pieces. So typically, like everything that you see in the web is typically rendered in HTML. It's usually styled with CSS. And the code that runs is typically either JavaScript, that's like the 99% case, but there's this thing called like WebAssembly that's gaining momentum, but we're not going to talk about that today. But that's an interesting technology for low-level, really fast code on the web. You can also just not have JavaScript running at all, and you can just have like a static website. If you think like something, let's say Wikipedia, for the most part, is very, very static, right? There's not a lot of dynamic stuff going on. But then when we typically talk about web applications, right, the word applications kind of infers that there's some interactivity going on. And that's the point where you definitely need JavaScript that executes some logic in the browser in your client. So you could just write that JavaScript by itself, and that's totally fine. Actually, that's not a bad place to start to learn the language. But especially if you want to build something really big, it makes sense to use other components, right? So that you can compose a big application made up of other components that companies and other users have made available for you. And there are just a gazillion web frameworks that could help you with that. A few of the popular ones, AngularJS is one that we'll actually see at the very end. jQuery has been around forever. It's pretty low level, but it's still being used quite a lot. There's React.js, also a very popular framework these days. There's Vue, another framework, and then there are like a gazillion. I have the feeling like every week there are at least like 5 new ones popping out somewhere. But I would say like these 4 are the ones that I would recommend taking a look at in general. And seeing like how they compare and what's going on. And we will take a look at Angular and a little bit of jQuery today as well. On the server side, right, server side now is very different because what is a server, right? Most here have probably heard about Apache. That has been around also forever and is driving a lot of the web. There's something like Nginx is being pretty popular as well. Node.js is coming up a lot these days too. And then there are the languages and the technologies that you use within these servers. So for example, in the past, there was something called CGI, where basically you just dropped any binary into a directory and it would be called once you made that request. Very low level, very insecure, very unstable, wouldn't recommend it. PHP though, right? PHP has been around forever. I would consider, it's not very cool anymore in a way, but a lot of the web is still driven by PHP. If you look at Wikipedia, if you look at WordPress, a lot of Facebook is using PHP. So definitely worth looking at, even though, it's not necessarily considered one of the cool languages again anymore today. JSP, servlets have been around for a while, ASP, Node.js, again, a lot of stuff that you can use on the server side. And then, so that's just your logic, right? But then on the server side, you then typically connect to many other services, right? You have databases to store stuff. You have authentication services to have your users log in. You have PubSub, like publish subscribe services, where maybe your website is sending notifications to an app that you're building on iOS or Android. Maybe you do machine learning, you need TPUs, right? So there are a lot of services that your web application might want to use. And we'll take a look at some of the Google Cloud offerings later, as well as like an overview. So, but that's kind of like the 10,000-foot view. And so again, we're trying to basically cover both of these today. We're going to start with the server technology, App Engine, which I think a lot of you have already prepared for this. And we'll then go a little bit into the browser side as well, a tiny little bit of jQuery, and like a little bit of an overview of Angular as well. So let's see, I think I already talked about most of this. Again, web server, there are many, many options available. If you actually, and it also depends on your use case, right? So depending on what you're trying to achieve, you should choose the technology that best fits your need in your situation. So for example, you could actually set up a physical machine, a physical computer with everything you need, like a web server, a database server, and everything. Really popular at the moment, for example, is to use a Raspberry Pi at home. So if you run something in your home network, set up Raspberry Pi. That thing costs like 30 bucks. Install Linux on it, and then you can have any server running on that one. Downside, of course, being you are fully responsible for the whole system, right? If something goes down, you have to try and fix it, whether it's the hardware, the software stack, it's your responsibility. On the other end of the spectrum, we have things like Google Cloud, Amazon Web Services, Microsoft Azure, and so on, where they're responsible for keeping services up and running, and you're only responsible for the part, that you wrote, the part that you're really responsible for. And then, that's not just a level of responsibility, but also a level of abstraction. So again, as I mentioned, like if you build your own Linux server, you're responsible for all the software that's running on there. You need to make sure that it's up to date. If there's a security patch coming out, you need to take care of it, which is a really big deal nowadays, right? And also the billing model might be different, right? You might be charged CPU time, the memory, the network bandwidth. But if you are looking at something like Google Cloud, and especially App Engine, which we are going to look at today, you have a much higher level of abstraction there. So also the way you're getting charged for it is different. But again, you're not responsible for scaling the service up and down or for keeping it up to date and safe. So yeah, it really depends on what you're trying to achieve, what you're trying to do, on what level or what tech stack you're going to use in the end. All right. Yeah, I think I already talked about this. Like as a side note, definitely look at everything that's around there and don't be distracted by all the new and shiny stuff, which happens quite a lot in like web development. Again, PHP has been around for a really long time and it's pretty popular still. So definitely take a look at stuff like that that's been around and compare it with the new stuff that's currently coming out to decide on, what's the difference? What's important to you and what's important to the application that you're trying to develop. So with all that said, right, so Google App Engine is one of the example web server technologies out there that I want to introduce to you a little bit today. I've personally worked with App Engine quite a lot. I've used it when it was still internal to Google, when they were still testing it, when it was only supporting Python and nothing else. So I've built quite a few services inside of Google and outside of Google on top of it. And I'm pretty familiar with it. And I kind of like what it offers. So App Engine, one of the nice things here is that it's not a server that you have to maintain, right? It's actually what's often referred to as, it's called serverless, meaning there's no server. You just write the code, you deploy it, it runs. Of course, there is a server, but you don't have to worry about that. You just write your code. It's also often referred to as platform as a service because the whole platform is there with all like the databases, the authentication services, the ML stuff, and everything you would need. You can just plug it into your application, use it, and you're only going to get billed for the stuff that you're going to use. Speaking of billing as well, the nice thing about App Engine is there's like a free tier that is actually pretty generous. So most of my private projects that I've done on App Engine, I've never had to pay a cent because I never actually reached that level where they would actually start charging me. Which also means I've never built anything really popular, I guess, but it's a double-edged sword. What's nice about App Engine as well is that it supports multiple languages. Again, as I mentioned, Python was kind of the first one that it supported. Java came afterwards. And since then, they've added Go, Node.js, PHP, and a few others as well. I think even .NET might be supported these days. So the nice thing is you can use the same platform, but you can choose the language and the frameworks that that suit you best. It scales automatically, which is a really big deal. So imagine you're writing a new application, a new service, let's say an Instagram competitor, and or TikTok competitor, and you rent a few servers, like 10 of them, right? You're like, okay, great, let's launch this thing, and let's say it becomes a huge success, right? It's on Reddit, it's everywhere, it's like everybody gets to it, but it turns out the 10 servers are not enough, right? You need more. You need like 10 times that much, 100 times that much. Well, now you have a problem, right? You can't just easily add a few servers. It's not that easy. However, if you have Service App Engine, it will actually automatically spawn new virtual machines for you to satisfy all the requests that are coming in. And not just that, if you have like an initial interest and then it apps down, App Engine will also just start to shut down these VMs again as it doesn't need them anymore. So that's really, really nice when you have any like platform as a service provider. It's again not just true for App Engine. There are other competitors that do the same thing. And again, it takes that problem away, right? You don't like all the scaling up and down. It's not really your problem. I mean, you should make sure that the code that you write can scale up and down, but for the most part, the system will do the rest for you. Yeah, and again, you don't have to. You're not responsible for keeping the service up and running. In this case, it's the Google SREs that have to keep it up and running. This is just like another note. There is going to be a lot of terminal work today. I mean, I think that just the life of a developer. I hope everybody is more or less comfortable with doing that. If you have any issues, again, let me know. But again, all that stuff, all the development tools that I show you today, it's all cross-platform. You can use the Windows Terminal or Windows PowerShell. I'm actually going to use here today the Windows subsystem for Linux, meaning it is running Windows, but I'm running Linux in Windows. But that's just a detail. Don't worry about it. But it's basically Linux that I'm using. But you can use Mac OS or, of course, any Linux terminal for this. So this one, I think I can just go hopefully pretty quickly through these because if I understand it right, this has all been shared with you before. But I can maybe just quickly, you can read it later if you haven't done this yet. But you need the Google account. You need a Java SDK. Since we are going to do the Java App Engine today, if you in the future want to try out, let's say the Python version, then of course you need to install that. So that's pretty easy to install. Maven is a build system that some of you might have come across already. That's something that we're going to use today. There are other build systems available. You don't have to use Maven for this, but again, in this example, that's what we're going to use. For anything Google Cloud, there is this Cloud SDK, which is pretty good and useful. So we're going to use that today as well. And yeah, so hopefully you've already gone through all of this. And again, I don't think we need to go through all of this. I hope everybody has done this. Sounds good. So this is, again, just to go through like initializing these projects. Here's the documentation again for later to take a look at how to in detail configure all of this. Once you have your project, it hopefully shows up. And I'm actually going to go through all of this like in a second. So I'm just going to go quickly through this because hopefully everybody has done this already. If not, it might be a bit late. But you can always go back to these slides and take a look at it again. Cool. Yeah. So this is basically, again, with like gcloud. So the gcloud command itself is something that you can use to manage all of your Google Cloud projects pretty easily. Not just App Engine, but and because of that, it would take too much space to download it all. So in this case, since we want to do App Engine and we want to do Java App Engine, you can basically decide to do this. Again, if you ever try to do like Python App Engine or something else, then you basically have to make sure to download those components separately. Let's see. Yeah, so Java App Engine, right? So it uses open standards. What I mean by that is, there are probably two ways you can go about developing a service like App Engine. Like one is to have all the APIs that you have to use to serve these requests to make them proprietary or unique to your system. But what Java App Engine actually has done is it has used a standard that has been around forever in the Java ecosystem, and that is servlets. So what are servlets? Servlets are actually pretty easy to understand, very simple interfaces that you can implement in Java that will then make a server, in this case, App Engine, serve requests from the application. So what do I mean by that? Let me actually switch over so we can see it with the concrete example here. This should be the right one. Yeah, here we go. So as you see here, this is, you hopefully have this open as well. This is the servlet that is included in the Hello World example that I asked you to install earlier. And as you can see, it's a pretty simple, it's a pretty simple Java class. Doesn't have a lot of stuff in it, but what it is, it's the class is demo servlet, and it extends the HTTP servlet. If you look at the HTTP servlet, it's not in any like Google namespace. In fact, it's like Java X servlet HTTP. And again, that has been an open standard for a long time. And again, App Engine has chosen to adopt that standard, which makes it really easy for experienced Java developers to basically add functionality here. So in this case here, take a quick look here. Yeah. So what this means is that we have like one method that is overwritten here, which is the do get method. Again, I haven't gone into these details here because it would probably take a bit too much time. But if you make a request from your website or from your client or website to your server, you can use there are multiple methods you can use to make that request. And the most common one is called a GET request. So a GET request is really just simply, here's the URL, like google.com or wikipedia.org/something. And that gets sent to the server. And then the server needs to figure out, oh, okay, here's what I need. Here's what I want. And then the server determines what to do with this request and what to send you back as a response. So in this case, right, here's like a do get method. And what you get as parameters, there's like an HTTP servlet request, which again is all the stuff that's coming from the client. And your job is to then use the servlet response to then send over a response to the client. In this case, again, it's like super duper simple. There are only like two things we're doing here. The first thing is we set a content type. Content type is somewhat important because, as you know, like on the web, you can serve many things. There's like text, there are images, there's audio. In fact, the HTML itself has a content type. You also have CSS, which is a different content type. You have JavaScript, you have JSON, and so on. So there are different content types that help a client to interpret the data that you sent it the right way, right? Because otherwise you just send back like a bunch of text, for example, and the client doesn't really know, what should I do with this? What is this? And if you tell it, oh, it's JavaScript, it knows, oh, great, it's JavaScript, I can execute this. Or, oh, this is a JPEG, great, I know how to display that. So that helps the client to figure out what it's supposed to do with the data. And then what you can do is, in this case, we basically get a writer that is included in the response and print like this little bit of text. And I'm going to go into what this little bit of text is in a bit. But that's basically all this servlet does. What we also have here in the app, so on the left side here, you see kind of like the structure of this application, which again, it's not very complicated. There's not a lot of stuff in it. The demo servlet is the only Java class that we have in here. And then all the other stuff is in this web app subfolder. The main thing we have right in the web app folder is this index.html. And that's just an HTML site. There's nothing else in here. So you can also, with App Engine, you don't have to render everything through a servlet. You can absolutely just put in, like, for example, images, static text, or in this case, just an HTML site that we don't want to change, that can be static all the time. We can just put it into the web app folder, and App Engine will just serve these as they are to the server, to the client. And then in the web app folder, you also have this webinf folder. And this is where you do all your configuration. So there are two files that are really important. One is the App Engine web XML, and the other one is the web XML file. App Engine web XML is actually pretty simple. This one, in this case, has not a lot of information in it. You can actually almost ignore all of this. It basically just defines which runtime we're using. In this case, it's Java 8. App Engine also has a newer runtime for Java 11, which has then a few other options. Not a huge difference there, though. ThreadSafe is just something that was added recently because Java App Engine wasn't always thread-safe, meaning, or it didn't need to be thread-safe, because App Engine would make sure that your code was always only executed once at the same time. But that can lead to bottlenecks, and it's not very efficient. So at some point they said, okay, by default, we're just gonna, your code must be thread safe, because we might call it from like multiple requests. And if it's not, you have to indicate that to us. So in this case, we're just explicitly saying, hey, code is thread safe, all good. And there are a lot more. You can like Google what App Engine, web XML, what other things you can put in here, because there's a whole lot of stuff. But then what's really interesting. Yes, please.
If that's okay? Okay, cool.
Absolutely.
This code can be found in your GitHub, correct?
That is absolutely correct.
right? Okay, cool. Just to clarify for everyone trying to follow along,
Oh
if
yeah,
you go in the chat, the link that the link's in the chat, and then so you click that, and it should take you to the code that he is looking at right now, and then you can copy that into your terminal, and you can follow along that way.
yeah, that's correct. Yeah, if you haven't, thank you so much, Alicia, for pointing that out. Yeah, this is basically an almost unchanged example. I can actually go here as well just to show it real quick. This is an almost unchanged example from the Google Cloud Platform GitHub repository. It's like the Try Java App Engine application. So yeah, you can totally find this here, and you can take a look at all the stuff that's included and follow along here.
Awesome.
Yeah, thanks, Lisa.
Are there any questions with that, with people that are trying to follow along? No, I can assume all 75 of you are following along.
Wow, everybody knows exactly what I'm talking about. I'm suspicious.
No, thank you. Okay, awesome. Sasha, you can continue.
Cool, will do. Thank you. So the other more interesting configuration file in here is the web.xml file. So this is the one where you define what will be served and how it will be served from App Engine. So the most important part is the servlet and servlet mapping subtext. So as you can see, this is all XML. I guess I didn't say that yet, but I guess that's pretty obvious. This is all XML. There is also, once you upgrade to Java 11, App Engine made the choice to then replace this with a YAML file, which is just a different kind of format, but it contains exactly the same information. But yeah, XML has been included in the older runtimes. So the way this works essentially is you define all your servlets here. And again, this is just an example application. There's just one here. But you can have any number of servlets that serve your requests in here. So in this case, what we say is, okay, there's one servlet, we call it demo. And then here you say, what class do we mean when we say demo, right? And that's exactly this class here, right, that I was just going through. So as you can see, it's called demo servlet, and it's in the package my app. So my app.demo servlet is the path to this class. So if we now go to the web XML file, you see that's exactly what's written here, right? So my app.demo servlet. So if you have another servlet that's in another package that's called differently, that's what you would have to then change or add. And again, you could easily just duplicate this servlet section here, and create like a demo 2 if you have like, like a second class here, and now you have a second servlet in here. Of course, you have to create the class as well. But that's basically how easy that is to configure here. And then, so now you have the servlet itself registered under this name demo. Well, now you also need to tell App Engine how to route requests to it. And that's something that we do with a servlet mapping right underneath here. So again, this demo here needs to map this demo up here, right? That's basically the unique ID now of this demo within this file. And then underneath where you see URL pattern, that's now to tell App Engine, okay, if the user requests /demo in the URL, that's what I want to then have routed to my servlet. And again, this doesn't have to match. I mean, I could call this one up here like demo 42, and that's still fine, right? And we could, for example, choose to have the demo servlet respond to all requests, and I could just get rid of the demo and call just / anything you go to would now be routed to that servlet. So you're flexible to basically map whatever requests you want to whichever servlet you want.
Are you using an IDE?
Oh, good question. So I would recommend using an IDE for this presentation. I'm basically just using Sublime. So this is just a text editor. Again, this is just because it's simpler to present it right now. But I would probably recommend using IntelliJ. That has pretty good support for App Engine. There's actually, I think on the slides, I'll show it later. I don't know if that was shared before, but there's a plugin for IntelliJ that is called, I think, Google Cloud Code that has built-in support for App Engine, and will add all the stuff that you need for it.
Do you have any examples with the Node.js?
No, I'm not. Yeah, I'm talking about Node.js today here in this presentation.
Okay.
yeah, at the time it just wouldn't have been enough. I mean, we will show Node.js very briefly later with an example with Angular, but yeah, I'm not going too much into that today. But good question. I mean, if you do use Node.js, another IDE that I can recommend for these kind of things is VS Code, like Visual Studio Code from Microsoft. That has been pretty good and helpful as well. For Java stuff, usually IntelliJ is probably the best option. For smaller things, Sublime is probably also good, but you won't get code completion and some more advanced features. VS Code 100%. Yeah, it's pretty good. VS Code is pretty good. I'm switching a lot of my development that's not Java basically to it.
Thank you.
Cool. So yeah, that's basically what web XML file is all about. And then what you also see down here, there's yet another section that's called the welcome file list. So what that means is these are some of the static files that you have that you want App Engine to serve like right out as they are. And that's again our index.html file that we added to the web app folder, or that has been added for us to the project. That is basically referenced here. So App Engine knows if we just go to / basically we don't ask for index.html, but we just say, hey, just load something. App Engine will serve index.html for us right out, which is pretty nice. And that's it. There's a logging properties file that you can ignore. That's just like, what log level we get. But that's really the core of this whole application. There isn't really much more to it, which is nice. If we look at any of the other files that are here, there is this POM.xml file, which has to do with Maven. So again, Maven is the build system that we're using for this. There are other build systems one could use, but that's the one that we use here. So that's really just that. And there isn't really anything else that is really important to now run this app on the web. Yeah. Any more questions about the servlet itself or the XML files that I just talked about? I would say let's see this thing in action. So I can actually talk a little bit about what's going on. So now we're here on my terminal. And I'm basically in the same directory, right? So if you take a look here, this is the same files that we just had. Again, the POM file is in here. If I go into source, we have main here. Again, here's web app with our index. HTML in here, right? So that's the same file. So all that stuff is now basically in here. If we go into webinf, we have all of our configuration files. They're here. And then if we go to source main Java, that is where we have our actual code, right? Here's, whoops, almost did that right. Here's our demo servlet again with the code that we have. So this is the same stuff that you just saw in my editor. And if I now go to the root of this, and I use, so basically one of the things that Maven also gives us is it gives us a few plugins for App Engine in this case, that let us run and deploy this application. So it's one thing is, you make these changes, you create your code and everything. How do you test it, right? You don't want to like push it to the cloud every single time you make like a little change. So what you can do is there's basically this one command here. So mvn is Maven. We want to clean everything. That's the first task you're going to run. And then we want to run app engine :run. And what that's going to do is it's basically going to run a local server for us. So I'm going to enter this here. And if the demo gods are with us, you see like it's basically starting up a little demo service. And you see here, okay, module instance default is running at localhost 8080. So localhost just being, my local machine and port 8080. So if I now go over to here, let's close this for now. You see like up here, I have like localhost 8080. If I hit enter, boom, here it is. Hello world, right? So our tremendously complex application is now spitting out hello world. And I can refresh this and, you can see it's basically a running service. What I've also done is just to show that, there's one small modification that I made to this application just to share how that is working, because as a developer, that's of course super important, and that is logging, right? If something's going wrong, you want to know where's your code, what is going on. Again, if you use IntelliJ, you can use the proper debugger, you can debug through your code and all of that. But let's just say you want to add some log lines. So what I've done here is I've added the Java util logging logger. As again, this is not an App Engine or a Google specific thing. This is just the standard Java logger that is being used here. I'm creating an instance of the logger right here. It's just a static final logger, calling it demo server. And then down here, I basically just say, hey, log info. Info is basically just the level of log. You can have like warning, you can have severe. That just means that the log lines are tagged in a different way. But I'm basically saying, okay, log out, this is a log line, hello S of hacks. So every time this method gets called, I should see this log line printed out. So I'm basically going to hit refresh here a few more times. And let's switch to my terminal, and you can basically see that, yeah, every time I hit refresh, every time I loaded this website, we do get hello SF hacks here as a log line, right? So this shows us, yes, this code is running, logging is working, all is good. And yes, that's basically it, right? If I make a change, of course, to this application, you will again see, you will basically then see the changes here right away. So for example, if I go to, let me go back to the editor. I mean, I guess this is pretty obvious at this point, but let's just say I want to have, like instead of hello, I want to say, so like hacks here, for example. And I then go back to my terminal. I'm basically just going to run that same task again that I just showed you. So let's go there really quickly. It has basically updated everything. It's starting up the test service again. And I'm just going to wait until it tells me that it's ready. So there it is. And I'm now going back to my browser. And if I refresh the page here, you see there's the updated text, right? So this is a way for you to basically very quickly update all of this. So yeah, that's basically it. So yeah, so somebody's already mentioning, oh, what about App Engine deploy? Very good segue. So now everything is running locally on your machine. That's great, but now you want to release it, right? You want to actually get it onto Google App Engine. So let's take a look how we would do this. So as a prerequisite to this, you should have already created a cloud project with a given name. And switch to that in your console. You can basically you can check basically what is currently going on and what is selected. If you do gcloud info in your terminal, you get a whole bunch of information about different, what's installed on your system. But at the very bottom, you should see something like this. You should see, let's see, can I actually do a mark? Yes. So you should see something like this here, where you see which account is currently logged in. And then also which project is currently selected, right? So in my case, I created a project and called it Web Dev Workshop SFSU. And that's basically it. There are like a few more details here about the account and what the environment is, but these are the two important bits and pieces here, that you're logged in and that a certain project is selected. And if you have trouble figuring out how to do this, if you go back to the slides, you will basically see how to activate that. So especially if at this point you have multiple projects going on, you can basically switch between them with the gcloud command. You can basically select a different project. In my case, okay, I have the right project selected with the right account and everything. So now I can go and I can say, okay, Maven clean App Engine deploy. Again, the clean is optional. It's just a good thing to do to clean everything up that Maven created before. So you started like a clean slate. And then we say App Engine deploy, which is now, so remember, before we did App Engine run, this is now App Engine deploy. So if I run this, it does, the first step is the same as the before. It basically just creates a package with everything that we just did. But instead of running a local server, you can now see it's uploading files to Google Cloud. And that should only take a little bit. What it's also doing, it's creating a new version. So you will see in a second when we go through the UI, basically every time you upload, I mean, you can change this if you want, but by default, it will create a new version for every upload that you create. And that's really nice because it means you can always flip back to an older version if you need to. And not only this, but if you have a production service at some point, you might want to deploy a new version, but you don't want to quite switch to it yet, right? You want to wait maybe until you have like QA teams like looked at it before or something, or you want to maybe split the traffic between two versions to make sure that your new version is actually correct. So this is why like having a new upload go to a new version is a really good thing. But I think this will get clearer once I share my web browser. So, well, first of all, if you look at my URL again up here, this is now on the Google Cloud instance, right? So this is the unique URL that you also just saw in the terminal. So appspot.com is the default kind of domain for App Engine applications. You can also map them to your own domain. We can, I'll have an example later, but by default, while you're developing, this is the URL that you can use. So let me refresh this, and we should all see the updated code that I just, you can see here, it now says FS Hacks World. And this is now on the internet. Even if you go to this URL now, you'll be able to see this. Maybe I'll actually paste this in chat. So if you go to this, you will see this just the same way I see it right now. And if we now go into the Cloud Console, so I think this was shared already earlier, but this is so this is now the Google Cloud Console. So this is basically where you can see and watch everything that your application is doing. If you go here to the top left of the navigation menu, you see App Engine as one of the items. In your case, it might not be up here. It is a bit further down under Compute. There's one nice little trick if you work a lot with the Google Cloud Platform console. For every entry here, in between here, you can select a pin. So once you pin something, these pinned items will then appear here at the top. So in my case, App Engine is always pinned. That's all the way at the top. The data store is something I do stuff with often. I want to log, and then Compute Engine. So these I have just pinned up here. So in your case, you might have to scroll down a little bit more. But it also gives you an overview of like all the stuff that is like in Google Cloud. And it's like a lot of stuff, right? But again, in our case, we're just dealing with App Engine for now. So if I click on App Engine here, oh yeah, another little thing like up here, right next to the Google Cloud Platform logo, this is where you have to make sure that you have the right project selected. If you only have one, then that's the only one that's there. But in my case, there are quite a few projects that I've created over the years and not deleted yet. So make sure you have the right one selected. And now I have the App Engine dashboard, and here you can see a lot of stuff. For example, you can see how many requests are being made to your application. You can see how many of them succeed versus fail. Again, in this case, this is just a test application. There are no real users, so you'll barely see any data here. But what's also nice is, let's first go here. So on the left-hand side, under App Engine, there's versions, because I just talked about versions so much. So versions is interesting because you can see I have two versions right now, and they're all tagged. You can actually give them a name as you wish, but by default, Maven will just by default generate a name that is based on the date and time. So this gives me a really easy way to just see what's going on. So for example, like 1841, so that's the one that I just deployed, right? And you can see it says serving 100% allocation, meaning 100% of the traffic that is going to this URL, 100% of it will end up on this version. And then you can also see an older version down here that I have deployed. And if I click on here, I can actually still reach this one. So this is now the older version that still says Hello World. And it's still available. And if, for example, something went really, really wrong with this new version, I could flip back to the old one by basically saying migrate traffic there. But again, this is going a little bit too much into the weeds, but you have all this flexibility with different versions going on. The last thing that I want to mention about this console here is in the left hand, you also have logging. So if I click on logging in Logs Explorer, I have basically all the logs that this App Engine instance is generating. So if I go here on Google App Engine and I take a look what's going on, I can basically see, I can see a lot of you have clicked on the link. So I can see all the requests that are basically being made to my server here. So on the left, I have the timestamp. I see here again the GET requests that I mentioned earlier. They're all GET requests. And then here on the right, I see the different requests that are being made. And there are basically 3 requests that are always repeating. There is just slash, there's /demo, and there is /favicon.ico. So you might wonder, what are these 3? Everybody's just going to this one link. Well, the reason for this is slash is what your browser is basically doing when you enter this URL up here, right? Sorry, not this one here, right? Because there's nothing, it's basically just the full domain name, HTTPS, webdev, and so on, and that's it. So let's basically go into slash.
Hey there.
/demo, yeah.
So we have a few people in the chat who are having issues getting their servers to run. How might you recommend debugging that?
Good question. Let me take a look. What are the errors that people are getting?
Okay, let's see here. Okay, so one.
Okay.
Yeah. So it might be easier if you.
Yeah, I'm reading it right now. Let's see. Good question. So I see like some folks have an issue with just like App Engine run. I see this right, and then some seem to have the problem even going to the web, which is probably a different issue, I think. Yeah, I don't. Just based on this, it's a bit hard to know what exactly is going on. What I could offer maybe is maybe after this, if somebody wants to reach out to me, we can maybe take a look. What might be the case with this specific installation that they're having problems with. I mean, it could be a firewall issue. That's possible. Yeah, but for example, error timed out usually means that your client or your operating system tried to connect to the application, but something didn't work, right? It didn't actually reach it. Like it didn't really receive a response in time. With the first one, actually, what's interesting, so the first one that I see here, I think Nawida, if I pronounce your name right, that's server error. So that is actually something where I would recommend to go to the Logs Explorer. So go to like console.cloud.google.com, go to the Logs Explorer, select the Google App Engine application, and then take a look at basically this area here. What you will probably see is you should see an error that's probably in red. And that would probably tell you a little bit more about what's going on. I had, for example, an issue yesterday. Well, I can probably not show it here because it was yesterday, where I made a mistake and I selected the wrong Java version, and basically App Engine couldn't serve this request. You would see exactly what's going on then here in this log. Yeah, I'm happy to, like, even after this session, if somebody wants to reach out to me, I see like there's like a Discord service potentially. To maybe do some debugging then, if that makes sense.
Yeah, we have our own like SFX Discord server, so if you wanted to join that, you'd be welcome to.
Happy to.
Let me grab the link.
Yeah, thank you. Because I think that might be more efficient, because I'm sure, I mean, there are always like different issues like here and there that people are having, and I think debugging them all right now might be a bit difficult, but I would definitely recommend, going to this Logs Explorer is like a good first step, and then we can take it from there. Yeah, thanks for pointing that out. Oh, perfect. There's the link. Ooh, I'm going to save this to go there later. Thank you. Oop. So yeah, so what you see right now is, again, you see like the slash request here. And then there's /demo, right? /demo, we'll get to that in a second. That is happening. And then there's also favicon.ico, which you can actually see responds with a 404, which means that it's not found, which is kind of interesting. But this is basically every web browser for a website tries to render like a little icon in the top left, right? So for example, you see up here, right, with GitHub, there's like this little cat icon. Like here, you see this little icon. For the slides, there's this. And so a web browser will make a request to favicon.ico to try and get that. In this case, we don't have one, but it still tries to request it. So that's why we see this here as well. And then also, like as a last bit, if we go to like /demo, that is our demo servlet from earlier. If I now go into this little like arrow here on the left, I can actually expand on everything that happened within that request. So if I go down here and I scroll down a little bit, we actually also see our log from earlier, right? So we see here our demo servlet is logging. This is a log line, hello SF hacks. So, so this is a way to get to your logs, and you can see then all the logs that are happening with one request. So the more and more your application grows, the more, of course, is happening, and you can see everything in here. You have the timestamps as well, so you can also debug performance issues potentially. Oh, and I see like we have one person now also with another working application. Woohoo!
I have a question. Can you
Yes.
build your clients directly on the Google Cloud platform for their web apps?
Yes, so there's actually, there is something that I haven't gone into at all yet. There's actually a cloud repository and an editor. I don't know, I think Melissa, did you try this out at some point? I remember you mentioned that to me at some point, that you actually followed a tutorial that did all the development within the Google Cloud application.
So I did try it out, if I think it's the right one. If you go to like the first Google Cloud Platform page, it'll have different instructions for different tutorials.
Yeah.
And
yeah, but there's definitely a way that you can do that, because you can basically upload your code to this project, and then you can also do cloud debugging, which is pretty cool. So I haven't done that in this case, but you can upload your code, edit it, and then you can also single step through your code within the Google Cloud project. Well, web UI in this case. So you don't even have to do that on your local machine in this case. But yeah, that's a good question. But I'm happy to show you as well how that goes. There are some tutorials about how to do that. It's something that I haven't really done myself in the past. I think it can be kind of nice, but I'm usually doing like the local compile and just upload the project way of doing things. Cool, getting more repos out. Sounds good. Yeah, so that's basically that. That's how you would then debug this whole application. Let's see. I know we're like getting out of time, so I think most of the stuff that's now here, I've already talked about, I think. So this is the deploy. We talked about that. We talked about all of this. Oh yeah. Again, like this is what I just mentioned. So if you want to use IntelliJ, you can go to the plugin sections in IntelliJ, and if you just look for App Engine, you should find Cloud Code. If you install that, you get all the App Engine functionality and all the other stuff that you need. So you can, if you don't feel that comfortable, for example, in the terminal, you can now manage all of your Google Cloud projects from within IntelliJ, which can be pretty nice as well. All right, let's see. So we've already done that. Yeah. So next steps, again, like we don't really have enough time to change this thing around a lot, but definitely play around with this. What I recommend, obviously, at some point you want to store some data. So I have a link here that basically shows you all the different ways you could store data using App Engine. So the three most popular ones, if you're familiar with SQL, you can actually use MySQL. That's one way to do it. The older mode that I've been using a lot is data store, and there's now like the new Cloud Firestore that you can run in a data store mode. That then allows you to use Java classes to basically store and retrieve all your data. And then there's cloud storage itself, where you can store like bigger files as well. If you deal with a service that has to like upload pictures, for example, and then serve them back out. That's a really good example for that. But that's maybe something like an exercise to the to the viewer to then like make some changes to the app to do that. And that's that. Yeah, just like a little like, at the moment, these apps are all hopefully responding pretty quickly. But if you, for example, just let it sit there for an hour and you're trying to access it again, it might take 5 to 10 seconds for your first request to respond. And that is because the again, the VM will basically shut down if there are no requests coming in. So there's no cost for you. And it'll take a few seconds for the VM to just fire up again and then serve your request. So yeah, we basically spent like most of this hour now just to talk about the server side. Let's maybe quickly switch over. What about client-side code, right? Again, there's like a huge number of frameworks and technologies. I mentioned this already earlier. You usually deal with HTML, JavaScript, CSS. There's the DOM, the document object model. That's really, really important to know a bit about, because that's basically what you have to modify to render anything on the browser side. JSON, super popular format to exchange data between the backend and the front end. And again, there are like a lot of frameworks like Angular that I have a little example here that I actually want to show you. What's also really important is to get familiar with tools that help you develop any kind of application. And one of those is the Chrome developer tool. So I briefly want to show you that because I think that's super, super valuable. So let's go back to this app here, right? This is running on Google Cloud. If you go to the three, so this is for Chrome, but Firefox has similar tools that are also just as powerful these days, so you can find them there. But if you use Chrome, in the top right, where the three dots are, where the menu is, if you go to More Tools, and then under More Tools, you go to Developer Tools. I don't know if Zoom renders this this menu, but if you go to the three dots, More Tools, and then Developer Tools, this thing opens on the right. And it is really, really powerful. You can basically, and the nice thing is you can use this on any website. You can go to google.com. You can go to Wikipedia, go to YouTube, wherever you want to go. You can open this up and you can basically see what the website is doing. On the top here, you have the tools that are really, the bread and butter of this. On the very left, you see Elements. So Elements shows you exactly what is shown on the left, right? So you can see like there's the HTML side, there's a header, there's the body, there's one div element which contains SFHack's world. And you can also see as I hover over this, on the left, you can see how it shows me what I have currently selected. So with a more complicated website, let's just go to this one here. This is like a website that I built a while ago, right? If I do the same thing here, you can see this one is a little bit more complicated on the right. But if I hover, you can see wherever I hover, that piece gets highlighted, right? So you can see like here, the individual div elements. As I hover over them on the left, they get highlighted. So this really helps you debug your web application once it gets a little bit more complicated. As you also select, let's say I select this container here. On the right, this is like CSS. Again, we can't go into the detail today. I'm sure a lot of you already know CSS, but you see all the CSS that is now associated with this one element. Yes, inspect element, very good. So that's another way you can get into this. Very, very good point. So for example, if I don't have this tool open and let's say I want to go and I want to see what's going on here, I right click and go inspect, and it brings you right into this mode. And what it does is it opens up developer tools, it goes into elements, and it basically it zooms all the way to the thing that I just selected. Yeah, very good point. Thanks for pointing this out. This is a super shortcut for finding that really, really quickly. Yes, Control-Shift-I on Windows. I think on the Mac, it's Command-Alt-I, if I'm not completely wrong. But yeah, that's basically what you can do here. And what's also pretty cool is you can just go in, let's say, here, you see like more info. That's right here. I can actually go in, I can double click, and I can basically, I can change this, right? I can say SFHacks, and now it says SFHacks here on the left-hand side. So you can really make a lot of changes. Keep in mind, you're not really changing the actual website, right? You're just changing the local representation of the website. Like for example, if I go to google.com, I can actually, here's I'm feeling lucky, or let's say Google search, I hit inspect, here's the button, right? And I can basically now make changes to that button. Let's say I want to make that button disappear. I can right click on it and delete, the button is now gone. Of course, I have not edited google.com. This is just a local change. As soon as I refresh the page, everything's back where it should be. But it's really a nice way to just help you debug things. So that's the Elements tab, right? In like a super quick way. Console is the other big one. This is JavaScript now. This is the JavaScript console. where if I log something, if there's an error, if anything that's happening, I'll see that in here. So and I can also, this is a live console, so I can actually start typing in here. For example, I could say console.log, let's see, let's do this, and boom, it just executes right away here, right? I can basically see directly what's going on. So that can be very helpful as well if you want to. So let's go to a more complicated website. Let's say this is GitHub, right? We can do the same thing with GitHub. If I refresh the whole page, you can actually see that there are like some error messages, probably because I have some some plugins going on here that block certain content. But you can see all the errors that you're getting, and you can basically then go in here and debug them in a little bit more detail. Super, super, super powerful. And then sources, that can be interesting as well. You can basically see where all the files are coming from. But network is the other big one, right? So if your web application is kind of slow and you want to see what's going on, if you go to network, you refresh the page, you can see everything that's being loaded. Again, in our example, it's pretty simple. But let's go to something like GitHub, and I refresh this page, and boom, you can see there are like 30 requests that are happening. And it's all different kinds of stuff. That's the actual document coming in. There are scripts being loaded. There are like graphics, like JPEGs being loaded. So all different kind of stuff, and I can basically see now what's being loaded in, and even like a preview. So for example, this one here, if I click on it, I go on preview, I can see, oh, that's my avatar logo, right? Or here's like a GIF, like, oh, okay, or a GIF, I don't know how you pronounce it. Or here, there's like a JavaScript file, right? I can click on these files and I can see what my browser just loaded, right? And also up here, you see like a timeline. You can see what has been loaded, how long it took, and so on. Again, we could probably talk half an hour just about that tool, but that's something to keep in mind that really helps you develop things on the client side. And maybe to answer the question of why here in the logs we saw slash, but also slash demo. Well, that is because if we look at our app here again, it did like the top here, you see that's the slash request. That's the actual website that came back. It then did a second request to jQuery. And then there's this third request to slash demo. And you might wonder, well, why 3, right? We only made 1 request. What's happening here? And just to remind you again, this is the website's source code. Again, this is just a slash request. This comes back to the browser. The browser sees, oh, there's a script that you want. So in this case, this example uses jQuery, one of these JavaScript frameworks. But in order to be able to use it, right, you need to import the source code for jQuery. So that basically happens here. We tell the browser, please load this. And so it does. You see this here on the left. And then our website also has a script in here. So this is JavaScript, where it now uses jQuery to load a JSON file from slash demo, right? So we basically tell it, please make a request to slash demo and load back that data. And that is that request here. So if we look at this one, we see the result is this construct, name world. And that is basically JSON data coming back. So we're basically creating a little temporary JavaScript object that has a property called name with the value world. And in our code, what's happening is we basically just say, okay, sfhacks, comma, that name, which will be world in this case. This is basically all that's going on here. But again, this tool is super, super helpful for debugging your client-side code. Let's see. I know we're pretty much over time, but I think these were kind of like the basics. I don't know, Alicia or Melissa, should we go into the Angular app at all, or should we just leave that as an exercise for
Can you show us how you link your domain to that?
Oh, yeah, happy to do that. Well, actually, so in my case, I don't want to say I'm cheating a little bit, but if you use Google domains, let's see, maybe I can actually show you this. So first of all, if you go, so this is like one of my projects that I've worked on. It's called RetroStore, retrostore.org. So if you go to retrostore.org, this website loads, but it's actually hosted, and I can actually show you this here. It is actually being hosted by App Engine. And here you can see the actual App Engine application. that is serving this website. So you can see some actual data. Again, it's not super popular, but oh well. But yes, so how you link it. So how you link it depends a little bit on where you have your domain, right? Typically what you do is you have to set your DNS record for your domain provider to App Engine and add your App Engine project ID, and that will take care of that. However, if you use Google Domains, which is what I have been using, so let's just go in here, my domains. I don't think there's anything confidential in here. And you take a look, these are like some of my domains, right? And if you go to retrostore.org in this case, you can see that I have this custom domain thing set up. And if I go to edit settings here, it has a way for me to basically tell it to do, where was this actually? It is somewhere here. There's basically a shortcut there where you can say, hey, this is actually an App Engine app. Put it there, put it on my web engine, App Engine. And then what it does is it basically fills out all these records that are basically the IP addresses of App Engine itself. And it will then register those with App Engine. But yeah, if you don't use Google Domains, if you use somebody else's domain, like I don't know, GoDaddy, for example, there's some instructions online for like how you have to set your record exactly, so that will forward to your App Engine application.
Well, actually, I use Google Domain. That's why I was interested in finding out.
Oh yeah, then it should be super easy.
Okay, cool.
But very good question. Yeah. Because yeah, you don't want to always use this like really long and cumbersome URL. I mean, it depends, right? If you just do it for testing, that's fine. If you want to use it as like a backend to like an application, that's fine. But yeah, if you want to make it like a shiny domain, then of course you want to map that to your App Engine application.
Oh, I have another question. So
Yes,
if you use Google Domains, are you still responsible for TLS certificate?
Come again? Oh, for what certificate?
For TLS.
I think that's a very good question. I think Google Domains takes care of that for you. Yeah, I think they take care of it for you, because if you look at this right now, right, this is so at the moment I'm using HTTPS to access this domain directly, but of course this is a different certificate. If you use Google Domains, you need to get a certificate for that new domain. And I believe Google Domains is using Let's Encrypt, if I'm not completely wrong, and they're going to auto renew it for you. But I can double check it after this. This is a really good question.
Thank you.
Yeah, excellent question. Cool. Any more questions? I don't know. Yeah, I was just wondering, like, I mean, we have like a little example here with like Angular, but yeah, I'm not sure if we should go into that one. That might take a little bit too much time.
I think we will send out the slides, and if people are interested, they can go into the slide deck and do it on their own. And we have this large community on Slack and Discord. So if you have any questions, you can always ping me or anyone else. And I think Sasha's joining the server as well. So that's a good way to keep in touch. Yeah.
Cool. Yeah. Any more questions about it? I know that was quite a lot to cram into like an hour and a bit, but I hope that made a little bit of sense.
Yeah, hopefully you can make some more videos or something else with the other stacks. That would be great.
Yeah, absolutely. And yeah, I mean, that's also the nice thing about the web, right? There's not just one size fits all, right? You can, like, again, Google has so many offerings, so has Microsoft and Amazon. And again, on the client side, there's so many different technologies that you can use to create applications. I mean, if there is interest, we could even like do, I don't know exactly, Alicia, Melissa, maybe there's like time to do like another session at some point with like just the client side and go into more advanced things like Angular, because that deserves its own hour, really.
Yeah, for sure. We can plan for that if that's what you guys are interested in. I mean, I would love to have another workshop like this. I think it was really successful. Sasha, if you're done, I can share my screen.
Yes, absolutely. Let me stop sharing here.
Okay, awesome. Let me share mine. Okay, a Q&A, and I know we already sort of started the Q&A, but you guys are all totally welcome to type in the chat or unmute yourself and ask Sasha questions about this workshop or just himself in general. He went to our college and he's obviously super successful now, and he's in the industry, which is what we all want to be in. So if you have any questions, feel free to ask them.
That's good. Somebody's asking what keyboard that is. I guess you mean this keyboard here. Well, that's actually just like a pretty simple M Audio MIDI keyboard. That's not that interesting. But yeah, I'm trying to make some music here and there, which is why this is here.
You should make music and send it into a chat, and we'll listen to it.
I could do that.
What kind of APIs do you use, or stacks can you use for payment systems from like B2C systems, if you know?
Oh yeah, that's a good question. I have personally really not used Annie recently, at least. There is one. What's the really popular one called? Yeah, I haven't really used one. What's it? Something with an S. There's one company that's like based here at the Stripe. Somebody say Stripe? Yes, I think that's what it is. Thank you. Yeah, I think Stripe, I heard, is pretty popular. I would probably take a look at that. Like one of my previous managers is actually a C-level exec over there, and so I think he's pretty good. So I think I would trust that, but I have no experience with it.
All right. Yeah, I was more interested in figuring out what kind of technology do they use? Do they use stack technology, or are they using actually really low-level machine programming for that?
Well, if you want to integrate payments into your web application, then they'll probably just have a JavaScript library that you will embed into your website, and then I guess you can just decide on how you want to use it from there. Okay. So one thing I guess we haven't even talked about at all yet, right? So these are all applications that are running on the same server. So what you would do in this case, if you have a payment service, you would have your website on yourdomain.com, wherever that is. You would include, let's say, JavaScript API from, let's say, Stripe. And now whatever you do with that API, that'll go to their servers, right? You would have an account with them, everything would go through them. So you wouldn't have to worry about hosting any of that actual functionality on your server, because they would do all the processing on their end. So yeah, on their end, they will probably have a lot of lower level code going on, but you don't have to worry about that because they have a JavaScript API. Likewise, of course, if you can then enter it or embed it into your iOS app, into your Android app, your web app, what have you.
Cool.
Yeah, good question.
So I'm curious, what classes did you take at SFSU?
Oh, yeah, what classes? I did, one of them was programming languages by Professor Dumovich. Is he still there? Maybe, doesn't ring a bell. So yeah, that was pretty, yes, somebody says yes. Yeah. Woohoo, yeah, that was pretty cool. I don't know what he's teaching today, but it was pretty cool to see like 5-6 languages that I wasn't familiar with, being taught and compared in the class itself. Oh, that's nice. Oh, I'm so happy. Yeah, Prolog. Yeah, that was one of the ones. I've only done this in his class, never before, never after again. But it was just super interesting to see that stuff. I think he did Pascal back then, Scheme. Yes, Scheme, exactly. I've never really done Scheme afterwards anymore, but it's so useful to know about, not because if you look at JavaScript or Java or C++ or C, Python, what have you, I mean, all these languages are kind of the same, right? But then in that class, if you do something like Scheme, that's really different. Prolog, very different. So I really, really like that. Oh, he does Ruby now. That's interesting. Cool. I think we did a bit of COBOL back then as well. That was horrifying. But so that was one of the classes I took. Let me see. I think I also did astronomy just because I wanted to do something else. So that was not in the CS department. And what else did I do? I think I did a class with Professor Pewter as well. Back then, I think it was the operating systems class. I don't remember quite, but with his train set and everything. So I helped him a little bit with that as well, I remember. But yeah, I mean, overall, I mean, one thing that I'm also often being asked, of like, what classes are kind of important for, getting a job at a company like Google? Like, how do you pass the interviews? Definitely, like, programming languages is always good just to know a bit more about, what's, how they work, but also just anything to do with algorithms, right? Algorithms, data structures. You don't have to know all of them, right? You don't have to know necessarily how to do like a quick sort from the top of your head, but just to generally understand how algorithms work. If you see one or you develop one, that you know what the complexity of that algorithm is. Things like O complexity definitions, right? That stuff is really, really important for almost anything you do at work. So knowing that really, really helps. So I would say definitely pay attention there.
You said O complexity?
Yeah. Like, for example, you have a data structure of, I don't know, 100 items, and you have a for loop that has to go once through the whole thing. That's like a complexity of n, we say, right? Because the array itself is n elements long, and you basically do a thing per element, which means like if the size of the array doubles, your algorithm now probably runs twice as long. If you have something that's like O(n) squared, that means like you have like a nested for loop, and that means every time your array becomes twice as big, it now takes 4 times as long to run, right? Which is usually not good. So that's basically like knowing these basics is really, really important, and something that is very useful.
All right, thank you. Do you recommend any books on that?
Oh, good question. I don't know any of the top of my head right now, but that's certainly something. I don't know exactly who's teaching that at SF State. Oh, there we go. Somebody says CSC 510 might be. Yeah.
Yeah, we have like 510 is our algorithms class.
There you go. So whatever they recommend.
Thanks.
Yeah, no worries.
I have another question. So
yes,
you said you've been with Google for almost 15 years. So like I'm wondering, like as a Google developer, like how do you see Google's experience in migration first from like monolithic applications, then to like containers, and then to like Kubernetes, because I'm asking because I'm doing an internship right now, and I just saw it like how company was like migrating first to containers, and then the next year like everyone is moving to Kubernetes, and it's just so crazy. So I'm wondering how like is company like Google, do you like have the same experience, or is it different in some way?
Yeah, super question. Thanks for asking. What's interesting is that at Google itself, like, so the stuff that we're working on, the actual Google products, we typically have a very different system and workflow to develop and push those. So we have an internal system, it's called Borg, that you might read about here and there externally, that we typically use to push new services out there. I think the main reason for this is just because like the way Google has grown and the scale at which we do things, like over all these like years, for like the last 20 or so years, the system has grown and grown and grown. So that is what's typically being used, and it's not really compatible with like either containers or Kubernetes, which is interesting, right? Because that's what we offer to our customers.
Right.
So there's actually this interesting divide at Google between, basically the functionality like the Google Cloud stuff that we're typically, offering to customers, And there are a lot of products at Google that use that technology stack. And these are usually the more newer products. Right? So for example, a lot of the things that I've been working on, as I mentioned earlier, I'm often using App Engine for Google internal products as well, because it's pretty stable and it does the job for me. But for anything like really super big, let's say like Google Search itself, Gmail, Calendar, all these really big things, they use like this internal stack that is a little bit different. So yeah, I actually personally have not really done too much with containers at Google myself. But I think it's slowly coming as well for new products, especially.
So if I got it correctly, for like internal use cases, Google would still stick to Borg rather than Kubernetes, because like your SRE team is more familiar.
Yeah, exactly. Well, not just familiar is one thing, but then also there's just a huge system, right, of like the infrastructure itself, the testing, the security that has been built on top of that is working really, really well. So one thing, we only touched on that very briefly now with this little tiny test app. You have so many services that have to, that support your instance, like all the logging, right? You might have alerts, you might have metrics. So all these things need to be in place to keep your service up and running, right? For example, if let's say Gmail goes down, right? We need to be able to detect that very quickly and then have our SREs on the case to take a look at what's going on, what component has been failing. So we have a lot of internal tools that monitor our processes, that take a look at any error messages that are spiking, memory, CPU load, what have you. So all these tools are already in place and very mature, right? So there's not really a need to move this to a different system at the moment, which is why there's still a lot of stuff that has been still using Borg to this day.
Cool, that's very interesting. Yeah, and thank you for answering the question.
Yeah, no worries. It's a really good question. Yeah.
Yeah, thanks.
If there are no questions, and if you do have questions, you can ask them after this. Before more people leave, we would love to get a group photo of everyone on Zoom just to document this moment. So I'm going to stop screen sharing, and Melissa, can you conduct the group photo really quickly?
Yes.
Okay. If you want to turn on your cameras, go ahead. And if not, no problem. We would love to see your face, but it's totally okay.
Yeah, I'm going to take a few because there are a few pages of participants. So once we get more cameras on. We're all right.
Camera's broken. It's okay.
I love Kevin's effects, by the way. This is like
I can also have
meme
Beyonce
game is strong.
If you want, I can have Beyonce with us.
Kevin needs to have a
nice. There you go.
for Zoom.
Oh
okay.
Love it.
Ready?
Yes.
All right, Beyonce's joining.
Oh, Kevin, you moved because you're adding Beyonce.
Okay, I'll take her off then. Sorry, Beyonce, you're done.
Okay, let me save this one. And then here's another one. Oh, wait, sorry. Okay. Oh, I think my Zoom froze. Can you guys hear me?
Oh, no.
Yeah.
Yeah, we can hear you. Here, let me try doing it. If that's
everyone.
Or do you have it?
Moving on mine.
Okay. Let me try doing this. Okay. Let's start over. Okay, I'll count on 3, and then we'll all say cheese. Ready?
Are you actually saying it?
Yes, 1, 2, 3, cheese.
Cheese.
Yes. Everyone say cheese. Okay, there's one more page, so let me get to the next page. You guys can keep saying cheese just in case you're on the second page too. Ready? 1, 2, 3. Cheese.
Jeez.
No.
Thanks, Orion.
Yeah,
Orion,
for sure.
Okay, awesome. Let's quickly wrap up this presentation. I'm gonna share my screen one more time. Okay, any other questions for Sasha? Keep in mind, he will be on our server in case you have any more. Okay. This is Melissa's slide.
So I'm sure a lot of you are on the SFSU Computer Science Slack. It is our main source of communication. There's about 3,000 people on there. And that's where I post all the ACM flyers. And I know SFX Hacks has a channel. So if you're not part of their channel, you can find them under the channels. And we have a lot of channels, interview questions. We post jobs and stuff on the interview and job channel. So explore the different channels, see how active they are, and then choose that channel. And it's most likely where we're going to be posting frequently on that channel. And we also have a website, sfsu-acm.club. We are looking for more people to join our dev team. So if you want to, please DM me and you can join our web dev team. And we're competing for a competition at the end where ACM picks the best student chapter website. So you can add that to your LinkedIn if you join us.
Awesome. Okay, here is SF Hacks slide. Our next workshop in the series is mobile app dev presented by Chris Creasy from Zillow. It'll be held on November 6th, so make sure to join that too if you're interested. These two QR codes link to our social media. Again, this is our server on Discord if you want to join. We're most active on this and on the Slack, and you can join our LinkedIn as well by scanning this code. So you can scan it now, or these will be out as well after the workshop. You'll probably see it by the end of tomorrow, the recording with the meeting slides. So just keep in mind, we have a bunch of other events happening, and this will branch out into the spring semester as well. As you can see, 129 will be AI. We're here. But yeah, just keep in touch with us through our socials and our server. Awesome. We would love to hear your feedback about how this workshop went, if it was too fast or too slow, or if Zoom, I don't know, was laggy for you, anything. Anything is helpful. So please scan this QR code and fill out the form. If you RSVP'd, you will get the meeting slides, the recording, and the form all to you by the end of tomorrow. So if you don't want to scan it now, you will get it tomorrow. And all I ask is for you guys to please fill this out. It's really helpful for us since this is our second workshop we've ever done, especially online. It's hard to gauge the feedback just by having a call over Zoom, like having a form is more concrete. So that's all we have for today. I just want to thank Sasha again for doing this for us. As students, we really, really appreciate it. Any last comments, Melissa, or anyone else? Any questions?
Just a thank you again to Sasha. And if you want to keep the conversation going, feel free to visit the Slack or the Discords. And if you didn't get your project working or have questions or you're playing around with it and want some help, definitely join one of the Slack or Discords, and there's a community there.
Mm-hmm.
It's good. Thank you again so much for having me. Yeah, I just joined the Discord, so feel free to reach out to me and ping me if you have any issues.
Yay.
Okay, I'm going to go ahead and log off. I hope to see all of you at our mobile dev event and our future ones as well. Okay, thank you, everyone.
Bye.
And our future hackathon.
Yes, and our
Bye,
future
y'all.